When you step up to a modern CNC machine, the entire manufacturing process begins with a single, simple motion, pressing the green cycle start button. The machine instantly springs to life. A heavy cutting tool plunges into a solid block of raw steel, tearing away material under high-pressure coolant. While the machine appears to move entirely on its own, every motion is part of a calculated sequence. Today, we are going to open the machine doors and uncover the exact chain reaction happening inside the system the moment we press that button. In our previous episode, we learned that CNC stands for Computer Numerical Control. That means the machine does not move based on human intuition. It relies entirely on a specific set of programmed instructions. Anyone can learn which button starts a cycle, but to operate these machines like a professional, you need to understand how a simple string of digital text turns into thousands of pounds of moving metal. Visualizing this physical sequence, from a line of code to the final cut, gives you the power to troubleshoot problems quickly and helps you truly master the art of CNC programming. The process starts with the CNC program. Think of this as a highly detailed digital recipe. It holds all the specific instructions for where the tool should move, how fast it should travel, and how quickly it should spin. But a recipe needs a chef to read it. In our machine, that role belongs to the CNC controller. The controller acts as the brain of the entire manufacturing system. On one side, we have our lines of code. On the other, the controller actively reads each line, interpreting those numbers into a coordinated plan. It acts as a translator, converting your written intent into actionable digital commands. A brain alone cannot move a muscle. It needs a way to communicate its plan to the heavy machinery. This is where the machine's electrical drives come in, acting very much like a nervous system carrying instructions away from the controller. The controller sends out thin, low-voltage instruction signals. The drives receive these quiet whispers and amplify them into massive electrical currents. Without the drives acting as this vital bridge, our digital math could never be converted into raw physical force. This wireframe highlights the precision motors and the three main directions of movement, the X, Y, and Z axes. Powered by the drives, these motors slide the machine's components precisely along these three-directional planes, allowing the machine to reach exact coordinates. But sliding into position isn't enough to cut steel. For that, we need the spindle. While the axes provide the location, the spindle provides the intense rotational force that spins the cutting tool. The axes position the tool anywhere in 3D space, and the spindle delivers the speed needed to slice right through solid material. All of this perfect movement means nothing if the raw material slides away. That is why the workpiece must be rigidly locked into place using heavy-duty work holding, like an industrial vise. With the material secured, the spinning tool finally makes contact with the stationary workpiece, carving away chunks of metal exactly as programmed. To ensure no mistakes, sensors act like the machine's eyes. They measure the motor's actual position and report back to the controller, which verifies the location with a green checkmark. This constant loop of action and feedback guarantees microscopic accuracy over and over. Let's map this entire process out. The CNC program sends instructions to the controller. The controller translates those into control signals sent directly to the motors and axes. Finally, the spindle and tool remove material, transforming raw steel into a finished part. When you press Cycle Start, you are triggering this exact sequence. This unbreakable chain from code to cut is what guarantees the high consistency and repeatability of modern manufacturing. This basic pathway from the digital brain to the mechanical muscle applies to almost all CNC equipment. However, different types of machines are built to move in vastly different ways. A CNC lathe spins the material instead of the tool, operating differently than a vertical machining center. And a 5-axis machine adds rotational movement that allows it to reach complex angles a standard 3-axis machine simply cannot. We will explore all of those specific machine types in our next episode. If you want to follow this complete journey from CNC basics all the way to advanced programming, subscribe to Learn and Grow with Fun, and I'll see you in the next video.